Today, we're gonna talk about the O-ring, O-R-I-N-G. Most of the mechanical engineer has used O-ring as a sealing component. Well, at least besides duct tape. O-ring is probably the most popular sealing device in the world. So, let's talk about something you didn't know about O-ring. To begin with, you may not even know what O-ring is. What is an O-ring? Some of you might open a Wikipedia page and see the following descriptions. O-ring is a mechanical gasket in a shape or tortoise in a loop of elastomer of a round cross-section, designed to sit in the groove and compress during assembly between two or more components, creating a seal bit at the interface. Well, Wikipedia is partially true. Most of O-ring are made from elastomer material. However, in some applications, they are made of PTFE, thermoplastic, or even metal. There is some variation in appearance as well, such as hollow O-ring or braided O-ring. So where can you see O-ring? It's literally everywhere, from aerospace application, heavy-duty machinery, cars, nuclear plants, pipes, hoses, food processing equipment, to toys. Some of them are even used as a decoration. Hard to imagine that, right? Check out this. It is amazing that simple design is able to play a critical role in ensuring proper seal and reduce the risk of leaking. Given the fact that O-ring is such an impressive product, let's move to our next topic. When was O-ring invented? In the Stone Age? Ancient Egypt? Or during Renaissance? Was it invented by the Grand Maestro Leonardo da Vinci? All wrong. This invention is surprisingly new. The first O-ring patent was granted in May 1896, which was invented by a Swiss engineer, J.O. Lomberg. However, the O-ring was not popular at that time, and United States independent inventor Niels Christensen designed a piston cylinder apparatus by using an O-ring as a seal. This design is developed for automobile brakes. Christensen received a patent from his improved O-ring in 1937. However, manufacture was not interesting until the aircraft boom during World War II. At that time, Christensen was be able to sell his O-ring to military after testing on Northrop lands. In other words, the simple O-ring enabled the advance of complex technology. Yes, the history seems to be surprisingly new. But do you know how primitive people seal fluid? Let us know if you'd like to know how ancient humans seal their tools and utensils. We'll create a new video to talk about that. Now, here comes the third surprising factor about the O-ring. The size of O-ring can vary from a couple millimeter to almost infinity large. The smallest O-ring commonly available is a syringe tip O-ring. The size of an O-ring has an inner diameter of 1 millimeter and a cross-section of 0.8 millimeter. The biggest possible O-ring that can be made can be literally unlimited large. That is, if you wish to connect the Earth and the Moon with a single O-ring, we certainly can help with that. It is because extruded O-ring core can be thermally and chemically jointed to extend its diameter. These O-rings are used in large construction seals and oil and gas equipment. In this convenience, to use a spliced O-ring which can be cut into whatever length needed for this application. However, the drawback using a spliced O-ring is its Achilles tendon, the joint. The joint will compromise the O-ring life and chemical resistance. When we talk about commercially available, fully molded O-ring, we are typically referred to those around 8 to 10 feet, depends on the material type. These larger fully molded O-ring are commonly using compressors, valve, oil gas equipment, large bore diesel engines, large high pressure vessel, flat panel display, and semiconductor manufacturing equipment. Next, the fourth fact about the O-ring. The most well-known O-ring incident. Most people have heard Space Shuttle Challenger disaster in 1986, while younger generation might not be familiar with this tragedy. On January 28, 1986, the NASA Shuttle Orbiter mission STS-51L and the 10th flight of Space Shuttle Challenger broke apart in 73 seconds into its flight, killing all 7 crew members. RIP. Weather forecasts for January 28th predict an unusual cold morning, with a temperature close to 30 degrees Fahrenheit or 1 degree Celsius. The minimum temperature permitted to launch is 1 degree Celsius. The overnight temperature was 17.6 degrees Fahrenheit or minus 8 degrees Celsius, because some ice built up around the solid rocket booster. The shuttle was never certified to operate in the temperature that low. The O-ring was made of fluoroelastomer, FKM, as well as many other critical components, had no test data to support any expectations of successful launch in that condition. The disintegration of vehicle began after a joint in its right solid rocket booster, SBR, failed at liftoff. The failure was caused by the fact that O-ring seal used in this joint was not designed to handle unusual cold conditions that exist at this launch. NASA has improved the design of 2 O-rings by adding an extra O-ring and heater to maintain the temperature above 50 degrees Fahrenheit. This disaster is a significant change to the rubber industry and raised the awareness of using proper O-ring design. O-ring and other seals are routinely batch tested for quality control by manufacturers and often undergo QA several times by distributors and the ultimate end user. The last fact you don't know about O-ring. Since the O-ring is so important, do you know the most expensive O-ring material commercially available? The most of the industrial use O-ring is made from synthetic rubber. The rubber tree produces natural